I invited a certain number of people to be on a panel discussion. If you would come on up to the stage. And we'll need some microphone runners as well. All right. This is a very informal. Here you go. This is going to be a very informal chat. This is designed to promote some discussion for you to have more over the banquet, but we'll just start this out. The forum is, what can we use? I think I should read exactly what it says on the paper here. Make sure I get this right. So we're going to spend about 25 minutes talking about how can ham radio further help ionospheric research. And this was a session that was proposed by Ed Dunlop over there. And I have a number of people on the stage, some of whom you have met already, and some of you have not met. So maybe we could just have the people who you haven't met yet just say a quick few words of who you are and why you're standing on the stage.
Okay, my name is Kate Zowdy.
Dr. Kate Zowdy.
Dr. Kate Zowdy. I work at the Naval Research Lab. I do modeling. I model the ionosphere. I model HF propagation. And I'm very interested in how the ionospheric changes affect HF propagation. I'm here because Nathaniel asked me to be up here. But that's what I'm interested in. So any data sources that we have are of interest to me because there's just not a ton of data for the ionosphere. So,
let's give it to Chris. We haven't heard from Chris yet.
Yeah, you'll be hearing from me tomorrow. But I'm one of the people who, rather than being a scientist and then learning about amateur radio, I was the other way around. I got my first license when I was 16. That's a long time ago. And then when I retired from the corporate world, I decided, science, I like doing that. So I got into the study of sporadic E, having been a lifelong 6-meter DXer. And this was 6-7 years ago. I was then had my arm twisted by Professor Catherine Mitchell at the University of Bath, saying, well, the best way we can help you is if you register for a PhD. So I said, that sounds like a load of work. And she says, well, it was a load of work. And I'm glad to say I finished it 3-4 months ago.
With Dr. Chris.
Thank you. It was a new experience being a student in my 60s. And my target was to finish the PhD before I reached 70, and I have succeeded. Yeah. Anyway, so that's me.
I'm Phil Karn, KA9Q. I retired from Qualcomm about 12 years ago, so I'm an engineer, not a scientist, as I always like to say. I'm past president of ARDC, and my interest has always been actually in engineering support of science. You can't do science without engineering these days, and I see all sorts of really interesting, neat little things you can build so the scientists can go get their data. That's it.
I'm Rob Robinette, AI6VN, and like Phil, I'm really more of an engineer than a scientist, but I've been really excited to be able to develop the, based upon WSPR spot measurements, a system to do that. With Phil's help, we've been able to extend the capabilities of the measurement systems, of which there are almost 100 different sites running WSPR daemon. Almost 15 of them, I think, now run Phil's software. And using Phil's software, and my colleague to the right, Gwen, will tell you, has shown some of the results of those investigations based upon my simple contribution, really.
Greetings, I'm Bill Lyles, NQ6Z, and I'm interested in anything that happens with the ionosphere from extremely low frequencies on up. And like Chris, Catherine Mitchell's been trying to force me to get a PhD, but I'm in my 70s, so I'm skipping that.
Hello, Gwyn Griffiths. I'm an engineer. My professional life was in oceanography. So I was using sound to probe an area of this planet that you can't really get to, the ocean. So now in retirement, I'm using electromagnetic waves to probe somewhere I can't get to, the ionosphere. I'm also a fan of detective fiction. We've heard of Sir Arthur Conan Doyle today. So Arthur Conan Doyle said, when you have eliminated the impossible, whatever is left, no matter how improbable, must be the truth. And that's 2 hop side scatter.
I'm Steve Serwin, WA5FRF. I think the same thing that attracts ionospheric research is the same thing that attracts hams. And at 11, I got interested in radio, and before that, I built a crystal radio, and those sounds. And then later, I got my license when I was 12, and my first receiver was an ARC-5 command set. That's a 1942 radio out of things like P-51s and B-17. Anyway, I still have a command set rig, but so I converted that thing and put it on the air, on the ham band, on 40 meters. And the sounds that came out of that radio after I made it work, you talk about mesmerizing. Some people like to listen to the sound of the ocean. I could go to sleep just listening to the ionosphere. Just the sounds are magic. So anyway, that's what attracted me into ham radio. It launched my entire career in science. I've taught college off and on in the evenings. I've spent a career at Southwest Research building instrumentation systems, but I've always included ham radio in the classes because it actually launched my career in science and was transformative. So I think the same thing attracts both.
Thank you, everyone. So I'm going to open up to the panel. We've already heard many things today, but maybe is there something that we haven't heard about today that we can use ham radio to help us investigate or learn something about the ionosphere?
So then I'll change it a little bit.
Yeah, it'll change a little bit? Okay.
Yeah. So WSPR is a wonderful data source, as you've been hearing and probably already know. But there is out there some WSPR reporters that are fake, some other things that are anomalous that aren't true, some people with bad locations. The difference between what scientists try to do is they want to make sure that they have precision and accuracy about the numbers. And hams don't worry about that so much. And as you kept hearing about GPS discipline oscillators, so what the ham community can do to actually help us do the science better is actually by using GPS discipline oscillators, getting the location specified better, making sure that the measurements they make are accurate. I mean, how many people actually calibrate their receivers so they know what the signal strength is that they're reporting? I mean, on the HamSCI website, there is a description of how to calibrate that receiver. So use it.
Yeah, as a communications engineer, I look at what's being done now and what you're trying to do with it, and I look at, well, WSPR is certainly being used heavily. WSPR is probably great for Doppler analysis. It's terrible for time analysis. As I said, I retired from Qualcomm. Qualcomm first got big by developing a form of spread spectrum called CDMA cellular. And I know that system pretty well. And one of the things I would like to do is take advantage of the new FCC rules that allow 2.8 kilohertz wide transmissions on HF to build basically a baby version of CDMA that could give us somewhat better time resolution, certainly better than they could do with WSPR now. Whether that's useful or not to you guys, I don't know. Hopefully it would be.
This is the thing closest to my heart right now, is to see that implemented. The WSPR receive sites, the WSPR daemon receive sites are ready to record those transmissions. Please give us the modulation technique.
And if you stop sending me late night support requests for...
Bill, too.
Here's perhaps a challenge to the professional community. So as a radio ham, when I try to look at the data that I've been working with, and I use Google Scholar, there we are in advertising there, Google Scholar, then often the papers that come up that seem relevant to the questions that I'm asking as a naive amateur are from the 1950s, the 1960s. And often in sort of professional proceedings. So maybe keywords or the topics have changed to what you as a professional community are working on today. So I use the word chasm in my own talk. What are the topics that are tractable and understandable both sides of amateur and professional?
Yeah, right. Okay, that is not a large set at the moment for papers that you'll be able to read from both of those communities, and that is something that we do have work to do on. People in this community, in fact, have started to try to write some of that. But there's what we can write in the community and distribute through places like HamSCI, and then of course there's the peer-reviewed professional literature, which honestly sometimes has a different goal. Okay, we won't go through the academic process right here, but this community could help by writing articles that sometimes for the professional look like, that's not going to get me tenure, okay, honest. I'm being very honest about this. But on the other hand, this is what we need to build communities like this. I was going to pivot just a little tiny bit because Kate is standing right next to me. And what I wanted to say was that that when we go to conferences now and people talk about models and people talking about comparing models with observations, uncertainties are a giant thing that frankly, we're still trying to train some of our professional colleagues how to use. You wouldn't be surprised how many plots at meetings don't have error bars on them. And very honestly, and that's a hard thing to do. So for the folks who are making measurements, that's getting to the top of the mountain, right? If you can make a robust set of uncertainties that people don't immediately say, this is so biased, I'm going to replace them with my own estimate or assume that they're all uncorrelated and constant. There's a place where I think that you'd start to get the modeling community really interested in pulling this in, because that's what they need for things like inverse methods and other kinds of statistically based, or even just to say, and don't use that stuff for these particular areas. So I don't know if you've seen that in your modeling work, but.
Yeah, that there's, well, let's see. You said a lot there. And uncertainties definitely are a thing that are not dealt with enough in our field. I know I'm guilty of that too, although I'll be honest, I'm not really a data person. I make friends with data people because I think data's hard. So I like playing with the model instead. But I think also kind of bridging the gap, one of the things that he said, you have to go back to a lot of the 1950s literature to get some of the basic information. So trying to put together a tutorial for tomorrow, there's not a lot of current places where you can go and find explanations of some of this basic stuff. And I think that's one of the real values of HamSCI, is to try and start bringing that together and making it a little bit more accessible. Because even for someone in the field, you really have to know where to look. I really had to pull from a lot of different sources to try and get something put together. So I think this community is very valuable for that.
Thanks, that's what I was hoping.
Yeah, I've also been through the process of trying to bootstrap my knowledge and trying to get into the academic literature and sort of learn the basis of the stuff that I've been studying. And it's been interesting and it's been daunting at times, but there have also been moments where I've been reading about something and I've been like, I see this phrase over and over and over again, and I finally realized from context they're talking about something that I understand in words that I've never heard of, and just basically putting together a dictionary is potentially a very valuable thing. Just helping people get into the topic is amazing, because there's been a lot of work done and there's a lot of value out there. Sure.
So all of that makes a lot of sense. But can I suggest that it's a two-way process? We have to make it a two-way process. The advantage that amateurs have in the context of science is, firstly, there's a lot of us all over the place, well, at least in places like the US and Europe. And secondly, we have a lot of practical experience. So, I mean, my particular area of research came out of me over many years saying, why the hell does it do that? Very much like that. And then so I'm going to find out. And then that turned into a PhD project and blah, blah, blah. So, yes, we need to communicate better, but actually people need educating in what the scientific method actually is. Because there are myths. There are so many myths. Sporadic E is caused by thunderstorms. That's... Yeah, well, quite. Now, actually, there's some basis for that, but it's only one of many, many, many factors. So I think we should be listening as well as talking, is what I'm trying. We the scientific community, because I'm sort of like this. But it's listening and talking, because what do amateur operators wonder about? What do they see? And they say, well, why does it do that? Those are the things they're going to want to know about, and they're more likely to contribute to, rather than just, hey, have some data and it all disappears into a hole somewhere. Sorry. I will rant if I'm not careful. Next.
I'll see you. Thank you. It seems like we are in a golden era of amateur radio for these things. I work with a lot of undergraduate students, and the Amateur Radio Club at Case has had good currency. We've gotten a lot of work done. We've gotten a lot of students through interesting parts of education that they wouldn't have otherwise. But they're not looking for a new hobby. They don't mostly want to get on 75-meter phone and... Yeah, right. They don't, no. On the other hand, the articles that ARRL and RAC were kind enough to publish for us about our CHU work instantaneously shook loose several hundred people who were happy to say to us, sure, I will press the button on transmitter lock on my beloved amateur radio station for 2 weeks and collect data for you. I will stop all of the amateur radio activity that I like and contribute my station's time to you. It's just amazing. All the Kiwi SDR owners who we politely asked, maybe could we have one of your internet channels for the day of the eclipse so we can collect data? They say, no, take all 8 channels and make them exclusively yours for the entire period that you want, 2 weeks. Okay. So maybe part of the question here is, what do we want to ask of manufacturers? People are buying a lot of amateur radio equipment these days. Do we want some feature included so that that equipment will essentially never be turned off? That if somebody isn't checking into the 8:30 traffic net for 10 minutes, their equipment's doing something that's of value to the science and engineering community. Maybe. What do we want to ask for?
Engineering thoughts on that, anybody?
I like it.
I like it. I am going to make a comment here that pulls on that a little bit. There was a period of time, actually, when I first began my graduate career, where instruments did not necessarily run continuously because they were resource intensive to run. And so people would get together at meetings like the ones that Nathaniel and Kate and I go to, for example, and organize campaigns. They would say, okay, for this week, we're going to throw everything we have at this particular topic. And then people would take the data afterwards and they would sort through it and they would find interesting things to do. It was a way of focusing people's attention. We now have a good and a bad thing in that we have a lot of things that just run all the time. And this is kind of referencing to what David said. When something runs all the time, it's a little harder to grab somebody's attention than when we have an eclipse. And then for 2 weeks near the eclipse, as David said, suddenly that focuses people's attention. And they say, oh, well, all right, for those 2 weeks, I could do something different and, take one for the team a little bit. So we've, even the professional community, have realized that campaigns are still valuable, even though you want some background things running all the time. And I think in HamSCI, we're sort of developing both flavors here. And so we have an eclipse, right, in April 2024, and the next one on the similar track is August 12th, 2045. We don't really want to wait till 2045 to have another campaign-focused event. So some of the QSO parties you've been doing and other sorts of things, I think we need to continue those focused events and have some regular cadence of them so that people who only can participate for a limited time know when they can show up and participate. And it's tractable for them, especially those of us, for example, who might have some other things to do at the same time.
You know, it might be kind of fun. There are a number of historical campaigns that have been done, like the transatlantic tests. I think there were some things that looked at, trans-equatorial propagation. You know, one approach might be to say, let's pick some of the historical ones and let's redo them with today's modern instrumentation and modern equipment and capabilities.
Yeah, and we actually do have a campaign planned, an ISR World Day for this fall. I think it's November.
Oh yeah. So we can yeah.
You're part of that group.
Yes.
and we should just translate, right, a little bit. So there are still instruments, maybe like the one I might be involved with, that are still very resource intensive and sadly cannot run the entire amount of time. So there is a way to get in a coordinated schedule where you pull these reasonably expensive assets in for a limited period of time, right? And there's even a process through ERSI, in fact, to get these things on the air if you have a given science case. And so some of us in the science community know how to do those proposals. And so, as Kate said, involving more of this community by kind of rolling along with a cart that's already going down the street is another way that but it's getting back to communication, right? Yeah. It is keeping track of everything we're doing here and keeping the bandwidth high so that we can spot these sorts of things.
Hams understand campaigns. They're called contests.
Exactly. It's a different phrase, Phil. It's exactly right. It's just, a different word for the same thing.
I thought the cleverest thing that was done when the HamSCI just started was Ward and Nathaniel and Magda put on a contest during the 2017 solar eclipse.
Right.
And got everybody and their brother to jump in. It was fabulous. So it's a couple of observations.
I want to just ask one more question. We're running out of time, but I do want to ask one more question. HamSCI is supposed to be a two-way street. How does ham radio help science, but also how does science help ham radio? So what does the ham radio community want from the science community? How can they help? David.
I want the microphone. All right, so those of you who are of my age, maybe I'm the oldest here, I don't know. In the 60s, they promised us flying cars. I want my flying car. They've been promising us, I'm looking, there you are. He moved, she moved so I could not make eye contact. They have been promising us inexpensive chip-level atomic clocks. I want my inexpensive chip-level atomic clocks. It's one of the things that I think we should be asking the manufacturers to include in equipment. It will facilitate much of this. So, science, help ham radio.
Yeah, I want to be able to do a relativity experiment with my HT.
What sort of information about propagation in the ionosphere do we want to ask from the professional scientists?
Right. What kinds of things would you like to see on a website that you can check? We had a talk by Andrew, right, who came up with a product which is just incredibly useful because it's visualized in a way that's very easy to grasp, right? And it gets to some of the variables that amateurs would like to know about. What other products like that would you like to see? How do you make the most of the time of your radio, for example? Anybody? No, not me. Hand it back.
Steve's got it.
I had one thing on the last question. The Whisper, the automated data collecting things work so well because they're automated and you can poll them. If you see something, say something. We have contacts all the time. I've lived through 3 total blackouts. Very strange. But don't do it like I do. I keep a paper log. But logbooks of the world today really make it possible to record a lot of contacts where you know where both stations are, and signal reports. If you do the signal report honestly, not your 590 man, what'd you say? But you know, if we would institute a electronic log with honest signal reports between stations, you'd get your data.
Dave Whitten, did you have a?
Well, some of this is reflected in things that have already been said, but from the perspective of what the group can do for the hams generally would be, I would think would be, well, the thing I keep hearing in so many of these discussions is time, precision, stability, and accuracy, and why your next radio will have some kind of, at least be BSDO disciplinable or something in a way that it may not be now. Why this matters to you, you know, proselytize that notion as an average ham, you know, because this has opened up so much of modern communication. There'd be no cell phones, no satellites, nothing without conquering time in the process.
Bragging rights.
No, but not bragging. I mean, no, you have to convince the average ham that his next claim on bragging rights will be that what his next piece of equipment is just this much more, that much more of a timepiece in a way, because it's fundamental, and it's fundamental to expanding new horizons for hams. Surely that if the more precisely you can control frequency, the more fine.
His vision is some old geezer 75 meters talking about Allen variances.
Well, you can wish.
On the crocodile nets.
Yeah, John and then Bob.
Who?
Yeah. And then you.
I'll have something to say when you're ready.
Great. John, Bob, and then Paul.
As Dave was saying that, I just realized something I have never heard mentioned in HamSCI is the ARRL frequency measuring test, which we do twice a year at least. And it's people who are now learning about the ionosphere. We've conquered the hardware.
Right.
And that's something that could tie into this, and we've never talked about it.
That's a great point. I think that's a really good thing for a campaign. I know from a little bit of what I know about the frequency measuring test in the past, I think it's mostly trying to identify the correct frequency that's been transmitted. But I think what we've seen is that's in many ways now the wrong approach, because you get a whole spectrum of frequencies. So it might be interesting to either rethink that or to use it as a campaign. I know that.
Do you want a word on the FMT?
Sure. Well, I know that a quick word on the FMT, and then we'll go to Bob and then to Paul, because I know David and Case.
Yeah, this is one of our big deals. We have an FMT competition team that does FMT for blood. Who knew that anybody want? Yeah, honestly, it's, you missed our president-elect. She's ill today, or she would have been here, Grace Ensberg. But she's our FMT coach. It's amazing. The history of it, though, has to do with regulatory issues. ARRL has used to run the official observer program. It has restarted it in a different form. Much of it was band edge identification. And back in the day, the frequency measuring test was to certify amateurs for class 1, 2, or 3 frequency measuring to do a pre-FCC notification of band edge violation. The Class 3 was 500 hertz. So if you had a reasonably well-calibrated receiver and could squint at the dial a little bit, you could be a Class 3 official observer. 2 was 50 hertz, 1 was 5 hertz, and that was exceedingly high accuracy at the time. The whole system went away when the accuracy of engineered goods became higher, and it got reconstituted as an engineering competition. It's really something quite different now. And yes, the equipment is so good that if you have ground wave, you can do a frequency measuring test just as well as anybody else can. The skill of it now is applying a statistical correction to your measurements to make your maximum likelihood estimator entry of the contest. And I see Jim nodding back here. During COVID, it was great fun doing these with 20 people on a Zoom panel, and everybody across the country was watching the Doppler shifts. I assume this is your kind of thing. Yeah. Do you want to say a word about FMT?
No, I mean, this is the idea is, and if you go to, it's a contest, right? And if you go to the people who get the green dot, you know, some of these people come in at 0.01 hertz, some of them even below that. But it's an art, because there is a thing you cannot control in between A and B. And you have a limited amount of time to receive the transmission as well. You know, it doesn't go on for 24 hours or anything like that. Although if it did, that would be even more interesting, wouldn't it? So there was another comment.
Yeah, I know. Okay, Gary. Bob's been trying. Let's go to Bob, and then we said Paul, and then Gary, and then I think we're gonna have to go to dinner.
Okay. To the comment about the signal report, the technology today of being able to give an honest signal report built into the receiver would be trivial for anybody to build into the receiver today. We got good A to Ds. We got and your comment about the frequency standard, we could make that into the receiver. Most of the receivers that have locking, or you can put in a proper reference, but they don't phase lock it. It's just something to keep the dial right. And so, a few suggestions to, we're paying $3,000, $4,000 for a receiver to put in $100 GPS receiver to lock up the receiver. I mean, it seems obvious to me, but anyway, I've carried on long enough here. But if the dial said the signal to noise ratio is 27 dB and the signal report is 549, and that's what you better report on the contest, then I think we'd get some of this traceability to our signal reports and to our data that we're trying to supply to the scientific community. And I'll shut up. Goodbye.
Thank you, Bob. Okay, Paul?
Yeah, thank you. The frequency measuring contest, it's been covered, but I think, could tie into that in many different ways, and I think that would be useful. What does the ham community, what do we get from the scientific community that would induce us, would excite us? I mean, I think you have to realize, I know you realize, all sorts of different communities in the ham group. Some want to talk to other people. Me, I haven't picked up a microphone in 10 years, and I like building stuff, and that's why I like being a ham, because it lets me do the technology, and I'm hardly unique. So give us interesting problems. Give us things that we can solve. That's what we live for. This, group of nerds like me, anyway. So that's one thing, and that's what got me excited into doing what I've done so far, is because, damn, that's an interesting problem. I think I can solve that one.
Fun. More of those.
The HARP in Alaska. Yeah. So, so Steve was saying that the HARP campaigns have been well received by the amateur community.
They had a real-time webpage. I tried listening for them, but it's kind of a guess.
Their links don't work.
I can let them know.
Please.
And Nathaniel, we should acknowledge our colleague Chris Fallon.
Yes.
Who just passed away, but was very instrumental in getting HARP to be outward-facing in some of these particular campaigns, and to realize that, no, it wasn't a squid mind control device. And some people would have you believe, but there was actually, not only was it doing science, but it could do things that are fundamental propagation tests.
Yeah.
And it's what just Phil referred to. The fact that you even knew that something was going on is a sea change from even a few years ago. And so I really want to acknowledge Chris in the work.
Yeah, so unfortunately, Chris, he was the chief scientist for HARP a few years ago, and he became an amateur because of his interest in his professional interest, he became an amateur. And unfortunately, he was very young, but he unfortunately passed away just a couple of months ago.
2 or 3, right.
Yeah. So I'd like to take a moment to. Yeah. That was, so yes, we definitely acknowledge him.
It is the general idea of, when somebody else builds a thing at the power level of the heart, please call me. I kind of like to use it. So we should continue to get them to be outward facing.
Yeah.
They haven't changed the transmitters since John Brosnan built them.
Of course.
Yeah.
But then again,
I want to use it after midnight.
Yeah, he did. Well, I mean, they still work.
And they have a summer school too, don't they?
They do.
So I wonder if there might be a way to get some amateurs or some HamSCI people to go to the summer school, because if we figure out to get some people to the summer school, then they learn how to propose experiments and actually work with it. That would be really neat. All right, I said Gary, and then we got to go to dinner.
Okay, one real quick ask, real simple, of the science community. I would like to be able to export my log from last year. It's 7,000 QSOs into Andrew's website. Tell it what antenna I have. It can come back and give me a report and said, you were successful. You made a lot of QSOs that should have been made based on the propagation, based on the data we've got. You've got a good antenna. Or it can tell me, you stink. So I need to go back to my HOA, figure out how to get a 20-meter dipole, operate for another 6 months, upload my log back in there, and tell me where I'm doing better or doing worse.
I like that. That's a good idea.
Or he tells you you violated the laws of physics.
Well, I'd like to thank everyone for a wonderful day one. Let's thank our panel. And thank all the people who came here to Cleveland. And thank you to everyone who's joined us on Zoom for all of these hours.